I'm Perminder Sachdev. I'm Professor of Neuropsychiatry at the University of New South Wales. I'm co-director of the Centre for Healthy Brain Aging at the university. As part of the Neuropsychiatric Institute, I've been seeing patients with dementia for a long period of time and see the devastation that Alzheimer's disease can cause to individuals as well as families. We've been interested in finding new treatments, applying novel technologies to both diagnosis and treatment of dementia. This research is a collaboration between our Centre for Healthy Brain Aging, the School of Chemistry at the university, and also the analytical school where the imaging part is done. And it's funded by the Dementia Australia Research Foundation. There are several parts to this research. The first step is to prepare the right kind of particle. And that's where the role of the Centre for Nanotechnology comes in. And the foundation's grant is funding a postdoctoral fellow to do that work.
The funding from Dementia Australia Research Foundation has allowed me to be a part of this really amazing team. I feel very privileged, and this research wouldn't be possible without them. I've been working with Professor Sachdev since the beginning of this project. I've been making nanoparticles that have magnetic properties to supply to the rest of the team so that they can test these with the Alzheimer's.
Once we establish that these particles are safe to use, then we see whether they are doing the purpose, in that they can cross the blood-brain barrier, therefore they reach the brain, and then they can target the protein that we want to identify.
The important part for our research is to synthesize and make the particles. The nanoparticles, because they are small, can go to different parts of the body. And importantly for this research, they can cross the blood-brain barrier, which means they can actually enter into the brain. And this means that we can use our magnetic particles to image parts of the brain to get information about dementia.
And once we do that, then of course we take these to an imaging facility to see that actually can we pick these particles in the brain at the right spot, in the right amounts, to be able to make a diagnosis of the disease.
Using nanotechnology in this way to detect Alzheimer plaque in an early stage is a unique thing across Australia, and only a few groups in the world use this technology. Dementia Australia Research Foundation funding allows us to do research this major clinical technology to improve how we can image plaque inside the brain at much earlier stage.
We know that Alzheimer's disease is the most common cause of dementia. It generally affects people at a later age, say after the age of 70 or so. But we know that the process of the disease starts much earlier. In fact, we know that Alzheimer's disease is because of the deposition of certain proteins in the brain. And this deposition starts 20 to 30 years before the disease first becomes manifest in an individual.
My role in this project is to make sure that these nanoparticles are safe and can adequately diagnose Alzheimer's disease in the hope that they will be rolled out for clinical use in the not so distant future. To determine whether these nanoparticles are specific and selective to Alzheimer's disease plaques, we used immunohistochemistry to stain mouse brain section. So what we found is that these nanoparticles can specifically attach to these amyloid plaques in a mouse brain. So what this means is that these nanoparticles can effectively diagnose amyloid plaques which are present in human MRI scans.
So the idea is that we need to pick this process early. If we are going to do something to disrupt this process, stop this process from happening, we probably have to act early. And therefore it's important that we diagnose this disease process at a much earlier stage. And that's what we're trying to achieve with this new technology. Thanks to the Dementia Australia Research Foundation funding, we should be able to do the initial steps of the development of nanotechnology for diagnosis and treatment of Alzheimer's disease. We will be able to show this at least in an animal model, hoping that then that will be transferred to humans in our next phase of research.